Dear students, good morning. This is Professor Mousam Sharma from Department of Mechanical Engineering, SISTec, Gandhinagar, Bhopal. Today we will be discussing about the method to calculate the velocity by relative velocity method. We will be solving a numerical as in a 4-bar chain ABCD, AD is fixed and is 150 mm long. The crank AB is 40 mm long and rotates at 120 rpm clockwise direction, while the link CD is equal to 80 mm oscillates about D. BC and AD are of equal length. Find the angular velocity of link CD when angle BAD is equal to 60 degree. As in the given data, NBA, that is the rotation per minute of link BA, is equal to 120 rpm, by which we can calculate omega BA, which equal to 2 pi n by 60. Put the value of n. We got omega BA is equal to 12.56 radians per second. To draw the space diagram, we have taken scale 10 mm is equal to 1 mm. Means 10 mm will be represented by 1 mm on the diagram. As AB is equal to 40 mm, in meters 0.04 meter. Therefore, the velocity of B with respect to A, that is VBA, velocity of point B with respect to A is equal to VB is equal to omega BA multiplied by AB. As we have the value of omega BA 12.568 and AB is equal to 0.04, which is equal to 0.503 meters per second. So first of all, we have to draw the space diagram for the figure. In this situation, we will move to the figure. As we are able to see that AD, horizontal line which is fixed, is 150 mm. By the scale we have taken it 15 mm, 150 mm, and we have taken 15 centimeter, and AB is equal to 40 mm, BC is equal to 150 mm, and CD is equal to 80 mm. As given in the condition, AD is equal to 150 mm, AB is equal to 40 mm, BC is equal to 150 mm, and CD is equal to 80 mm. But we have taken scale 10 mm is equal to 1 mm. So the AD line will be drawn 15 centimeter, AB will be drawn 4 centimeter, BC will be drawn 15 centimeter, and AD will be drawn 8 centimeter. And the angle DAB is equal to 60 degree. So by the scale you have to draw this space diagram. This is called space diagram. After drawing a space diagram, we have to draw a vector from point B showing velocity of point B with respect to A, which is perpendicular to the link. As we have drawn VB, a vector perpendicular to AB. As the link is rotating clockwise direction, so I have given the direction downward. So draw a vector VB perpendicular to link AB. Always remember that velocity vector is perpendicular to the link. Similarly, we have drawn two links vectors which are perpendicular to CD as well as CB, as C point is moving relative to D as well as B. So we have drawn two vectors VCB and VCD. Vector VCD perpendicular to link CD and VCB perpendicular to BC. Remember that perpendicular should be perpendicular. So this is the space diagram for the given figure. As we have calculated the velocity of point B with respect to A as 0.503 meters per second. So we have to take scale for velocity diagram. I have taken 0.1 meters per second is equal to 1 centimeter per second. You can take scale by your convenient. So by taking this scale, we have to draw the velocity diagram. First we have drawn space diagram. For finding velocity, we have to draw another diagram which is known as velocity diagram. Space diagram is always shown with the capital letters. Space diagram is always shown with the capital diagram, and velocity diagram is always shown by small letters. Now we have taken a velocity diagram as in the figure. First of all, take the fixed point on the space by your choice. Fixed point, as we have taken A and D as fixed point in the space diagram, so I have taken AD in the space. First take a point AD in the space which are representing the fixed point. Now as we have seen that vector VB we have drawn which is perpendicular to link AB. So draw a vector VB from AD. Draw a vector VB from AD which is parallel to the vector which we have drawn in the space diagram, this one. Draw a vector parallel to VB. So this line is showing a vector parallel to VB which we have drawn in space diagram. This vector is showing the velocity of point B with respect to A. As D is also fixed point, so we have taken same point. Whatever the fixed point should be taken similar on the velocity diagram. So by the figure AB vector VB showing the velocity of point B with respect to A. Now we have drawn two vectors in the space diagram as on point C, it is VCD and VCB. Take these two vectors in the velocity diagram. As we have seen, VCD in the space diagram at point C, this VCD in the velocity diagram VCD. Similarly, the VCB vector in this diagram. So from point B, draw a parallel line which is parallel to VCB which we have drawn on point C. From point B in velocity diagram, draw a parallel line showing VCB as parallel to the VCB vector drawn on space diagram at point C. So at point C we have drawn VCB, and in velocity diagram we have drawn VCB. Draw this line and a parallel vector to VCD at point C and VCD in the velocity diagram. These two vectors are meeting at point, that is point C. So this is a closed velocity diagram showing VB, VCB and VCD. By this diagram, measure VCD is equal to 0.385 meters per second by converting scale also. So we got VCD is equal to 0.385 meters per second. So these two diagrams can be drawn simply. First you have to draw or take AD which is fixed point. From here draw a vector parallel to your velocity vector VB. From here B point draw a vector parallel to VCB, and from point D draw a vector VCD. These two vectors are meeting at point C. So this will give you the velocity diagram. So by measurement we got VCD is equal to VC is equal to 0.385 meters per second. As CD is equal to 0.8 meters, therefore angular velocity of link CD, omega CD is equal to VCD upon DC, which is equal to 0.385 upon 0.8, which is equal to 4.8 radians per second. So we got the angular velocity of link CD as 4.8 radians per second, which is moving clockwise direction about D. So by this we have solved a numerical of 4-bar chain with finding out the relative velocity method for a link CD. Thank you.